Hello my dears. Now we are going to discuss about change in rotor angle during fault condition. So we are moving slowly deeper into the concept of transient stability. So for the full understanding of transient stability, we required these topics now. This concept is very important for the understanding, very good understanding of transient stability and equal angle criteria. We are moving into equal area criteria. It is not a sudden process. Before that we should learn many things, then only that concept equal area criteria. In syllabus it is simply equal area criteria and stability analysis. But if you do in a lecture, it takes so many effort and it will take so much time in order to convey the concept of equal area criteria. So before that, we have to see what is meant by changing the rotor angle during fault. See my dear, what is the swing equation? Generalizing equation. What is generalizing equation? The swing equation normally, which is equal to our m into what is that? T square del divided by dt square is equal to Pm minus P, where Pm is nothing but the mechanical power input or the shaft power, or simply we are rotating that power. P is nothing but the electrical power. So under steady state condition, what Pm and P will be same, so that simply can say that Pm minus P is equal to nothing but Pa, because if whenever there is a mechanical energy input which is higher than the electrical energy output, always the alternator is in accelerated position. So this is called a PA. It is called a PA. Or d square del divided by dt square equal to PA by M. D square divided by dt square is equal to what, my dear? PA by M. Is it clear? I am multiplying both sides with 2 into d del by dt. 2 into multiplying both sides with 2 into d del by dt. Okay, 2 into d by dt. 2 into d by d del by dt. Multiplying 2 into d del by dt on both sides. See my dears, see, listen. This is equivalent as d by dt of d del by dt the whole square. Can you check this is same or not? Can we check? Suppose, see, d by dt of d del by dt the whole square is what? 2 into this one, d del by dt, right? 2 into d del by dt raised to 2 minus 1, it is simply 1. So 2 into d del by dt into d by dt of what? D del by dt, which is nothing but, my dear, d square del by dt square. Am I right? Am I right? So if you have any doubt, put a constant as this. Put for checking, put x is equal to d del by dt. You just imagine. So substitute here d by dt of, okay, instead of x, a time function will be there now. Put t is equal to, right, correct, 2 is equal to d del by dt. Okay, so what I get? D by dt of t square, correct now? D by dt of t square. What it is that? 2t into dt divided by dt. If it is a function of t, that is why this is dt by dt happen. Simply you take it as a function of x. So what happens? X square means I can say that 2x into dx by dt. Am I right, my dear? So 2x means simply 2 into this x is like d del by dt into what? Dx by dt into 2 into x. Instead of x is that to dl by dt, or d by dt of d delta by dt is what? It is 2x into what is x now? X is nothing but d delta by dt. So d delta by dt into d by dt of d delta by dt. So what is that? D square del by dt square now. So finally you will get 2 into d del by dt into d square del by dt square. Correct or wrong? Correct. So this is same na this. So this is can be equal to this one. That is my aim. Okay. That means d by dt of d delta by dt square is same as that of 2 into d delta by dt into d square del by dt square. That was my aim. Okay, my dear. So I can omit this. I think you got the idea, right? Basic differentiation, that's all. So d by dt of d del by dt the whole square equal to what, my dear? 2 into pa by m into d del by dt. Am I right? Taking integration and dt, integral dt on both sides. Integral dt on both sides. What I get? This dt and dt gets cancelled. This dt and dt gets cancelled. So the remaining will be simply d del by dt the whole square. They are nothing for the integration purpose. That's why dt already cancelled. There will be nothing. Simply d by dt the whole square only will be remaining. So d by dt the whole square will be equal to, am I right? If anything for anything is there for the integration, then you can integrate it. But there is nothing. dt and dt got cancelled. So simply the constant will be reflected as the integration result, right? The constant will be reflected as the integration result. Okay, and which is nothing but, my dear, integral, that is 2 into pa by m is a constant, integral d del, integral simply, this is, you can write like this. Okay, this is nothing but, my dear, 2 by m into integral pa d del, integral pa d del. Is it clear? Is it clear? So what it implies, my dear, what d delta by dt or d del by dt the whole square equal to 2 by m into pa d del, which is nothing but, my dear, 2 by m into, what is this, integral pa? Integral pa is nothing but, my dear, pm minus p into d del, or that pm minus p is nothing but, my dear, 2 by m into integral pm is mechanical power input, pm minus p is nothing but, my dear, p max into sin del. Am I right? P is nothing but EV divided by x into sin del. Na? EV by x is nothing but P max, right? So it can be written as P max into sin del d del. Pakka. Okay. So I can write like d del by dt is equal to root of 2 by m into integral Pm minus P max sin del d del. It's very important relation. It's very important relation, my dear. So this d delta by dt is nothing but, my dear, changing rotor angle during fault. Changing rotor angle during fault is equal to 2 by m is moment of inertia. Either you can substitute for gh divided by pi f or gh divided by 180 f, or simply h divided by pi f in terms of per unit for m. 2 by n into integral Pm minus P max into sin del d del is the equation for what? Change in rotor angle during fault. Changing rotor angle during fault condition. Okay. Is it clear, my dears? Is it clear? Is it clear? So can I run this? So if you are drawing the variation of del with respect to time, Array. Straight line. It's very difficult, right? Okay, I will try it now. Correct. Listen, my dear. So this is the expression for d del by dt during fault. So what happens at fault? If you are plotting a graph between the time against the changing rotor angle del, what do you get? Initially up to del 0, initially up to del 0, the machine is operating in a stable manner. There will not be any change in del, it's smoothly running. Suddenly at point del 0, there is a fault occurred. Then what happened, my dear? It will suddenly jump into an oscillation process. The rotor will be suddenly jump into an oscillation process. That means the rotor angle will be suddenly rise to, from this point to this point, suddenly rise to del 1. So this is the rotor angle. But the rotor angle will not suddenly reaches del 1 as soon as the fault occurs. This del 1 is the new rotor angle, because as soon as the fault occurs means what happened? What happened means why the rotor angle is increasing during the fault condition means during the fault condition what happened? Voltage is suddenly dropped to 0. If voltage is suddenly dropped to 0 means PE will be normally 0. If P is equal to 0 means you can substitute there in the previous equation PV as 0, because when P is equal to 0 means there is only accelerating power which is produced by the mechanical shaft itself. The acceleration power is there means motor or the alternator rotor angle will be very high. So the rotor angle will be jumping to del 1, but the del 1 is not suddenly acquired. Before that it will goes to a very big rotor angle del max, and it goes to some oscillation. It after some time it is settled down, and finally only it gets into a new rotor angle del 1, and del 1 is nothing but its new stable operating point, and at that point d delta by dt will be 0. At that point d delta by dt is equal to 0. So I can say that, my dear, I can say that this Pm minus this P max into sine delta, this is called what, my dear? PA, am I right? PA, accelerating power. So I can say that under steady state operation, under steady state, what I can say that integral, that is under steady state, d del by dt is equal to what? 0. D del by dt is equal to 0 means this is equal to 0. This is equal to 0 means this RHS will be equal to 0. This RHS will be equal to 0 means I can say that integral PA d del, integral PA d del, this is very important fact, my dear. PA d del is equal to 0. PA d del, that is, this is PA and d del will be equal to 0. This is called the equal area criteria. We will show it graphically in the next lectures so that it will be more and more clear. But for us, no, integral PA d del is equal to 0 means PA is nothing but acceleration power. The net acceleration power equal to 0, which indirectly tell us that the total acceleration, this integral is nothing but, my dear, area. Correct, na? The integral is nothing but area. So the total area of acceleration power will be 0 means there is someone or there is something in the region, or there is something in the curve, or there is something in the graph or plot which equal and opposite to the acceleration power is there. That is why the net acceleration power will be equal to 0. See, if I am saying that my net velocity is 0 means my net velocity is 0. Suppose I am saying my my relative velocity is 0 means, how can I see that my relative velocity is 0? If someone is there which is moving equal to my speed, then only I can say that my relative velocity is 0. In similar manner, if the acceleration power is 0 means if someone is there which equally try to decelerate its acceleration, then only I can say that net acceleration will be equal to 0. Am I right or wrong? Am I right or wrong, my dears? Is it correct? Did you get the idea? I have already told you that this is not a simple concept. The power system analysis is not that much simple, my dear. That's why only in higher level of examination you can see the problems regarding this. In lower level of examination, only the power system one, the transmission, distribution and consumption, only you can see there. Okay, generation, transmission and distribution, that's all. But higher level examination will cover the transition, stability or steady state stability, all concept. So it is actually, you have to imagine a lot, you have to think logically a lot, no? Then only you will get the idea of what's happening inside the alternator. Okay, so I will try to deliver as simple as possible. Okay, watch 2 or 3 times the video if you are not sure. Prepare your own notebook, okay, and write whatever I am saying in your own language before moving to the examination. No? You have to revise it now. So while revision, if you simply skip the wordings that I am uttering and you simply drawing the graphs and all, after some weeks you will not remember anything, because it's that much deep and that much difficult concept. Okay, so please take care and please be careful. So equal area criteria says that what I already told you means integral PA d del equal to 0, which implies what, my dear? Area under acceleration equal to area under deceleration. So this is called the equal area criteria. Okay, equal area criteria. So this is called what? Equal area criteria. Is it clear, my dear? Is it clear? Okay. So in the next classes we will discuss how we get the area equal to 0 and what are the factors affecting. Okay, the analysis much deeper. Okay, thank you so much.